Good morning, everyone. It is my pleasure to introduce Kattni. She is the chair of the Pi Ohio Conference and one of the core developers of the Beware project. She will be talking today about switching from Sphinx to Markdown. Please make her feel welcome.
Thank you. Hello, everyone. I'm Kattni, and I'm here to talk about switching from Sphinx to Markdown. A bit about me, as I've already been introduced. I'm a core developer on the Beware project, where my primary focus is documentation. And I acted as the technical project manager for the Beware documentation infrastructure migration from reStructuredText and Sphinx to MkDocs and Markdown. However, the more important thing you need to know about me is that I am tolerated by a cat and 3 kittens who continue to let me live with them. Today, I'm going to talk about restructured text in Markdown, the associated documentation options, and what goes into migrating a substantial existing set of documentation from the first to the second. This project involves several tools which are mentioned throughout the talk, and you can find a full list of resources linked at the end of the talk. I want to acknowledge ahead of time that you may be aware of MkDocs due to a shift currently happening in the ecosystem. I will be expanding on that towards the end. The important thing to know as heading into this is that everything I discussed today is still relevant and applicable. So restructured text, or REST, not Rust, but REST, is a markup language primarily used for documentation in the Python ecosystem, though it has seen adoption elsewhere as well. Python needed a better way to do documentation than the existing LaTeX-based system, and REST was designed with Python's docs in mind. Sphinx is a documentation generator developed for and used by the Python ecosystem, though it has also seen adoption by various other projects. REST gives you a way to format a single file by providing, or to describe as a block of text as, for example, bold, italics, or a paragraph. Sphinx lets you create a set of related documents that are interlinked with additional tooling and plugins for specific tasks like API documentation. One of the main reasons that REST is still used in the Python ecosystem is because it is a capable tool, but it has an extensive history as the Python documentation format. REST has been used in Python for 23 years and Sphinx for 18 years. CPython 2.6 replaced LaTeX with Sphinx. Other projects, such as Django and Beware, have continued to use it because it was used by everything that came before it. However, there are alternatives. Markdown is also a markup language for creating formatted text. Markdown was designed to be a human-readable, human-writable solution to document formatting that can be easily converted to HTML. It was originally written to simplify blogging. The web is based on HTML as a markup language, but HTML is verbose and unwieldy for a human to write. If you're writing a blog, you need to be able to produce HTML quickly. This is where Markdown came in. However, it's become much more widely used. Markdown has been adopted across many tech ecosystems. Nearly all major messaging platforms, including apps like Slack and Discord, support using it to format messages. Many text and code editors not only support it, they have a rendering preview feature available. GitHub chose Markdown to be the default format, going so far as to develop their own flavor, GitHub Flavored Markdown. While GitHub does support other formats like REST, there is a fairly strong internal preference being expressed. AI is built around processing human-readable text. The simplicity of Markdown being able to move to HTML from text has worked to its advantage with the AI text processing pipeline. If you look at the UI for LLMs such as Claude or ChatGPT, they all accept Markdown formatting. Markdown is now a viable alternative to REST for documentation due to the development of various tools. There are several options, including platforms such as MkDocs, Docsify, Docusaurus, Gitbook, and tdoc, as well as Sphinx when using the MIST parser. Essentially, MkDocs, etc., is to Markdown as Sphinx is to REST. So how do the two formats compare? In terms of what it does well, REST provides rich cross-referencing of multiple documents of content. And it was, for a long time, the only option for using Sphinx, the combination of which was originally the only backend supported by Read the Docs. As for difficulties it presents, REST was not concerned with being human-readable. The link syntax is obtuse at best. Originally, you would describe the link, then define it at the end, but this was a little bit awkward to write. In theory, it helped when links changed or were referenced in multiple places, but the prevalence of multiple link references is limited, and therefore so is the benefit. The more recent link syntax is very white space sensitive and doesn't allow for markup language in the link text, including formatting text as code. This is an example of a simple document using REST formatting. It contains a document heading followed by a paragraph that includes bold text, strike-through text, and a web link. The strike role and class must be included at the top to render strike-through text. However, as I will explain, that doesn't even work on its own. It requires a separate CSS element to then render the strike-through as such. The number of equal signs around the heading must always match the length of as the heading text, so you have to remember to update that if you alter it. And to render properly, the link must include the backticks, the space between the text and the URL, the brackets, and the final underscore. Markdown, what it does well is it was designed to be human readable and easily converted to HTML. Reference links are written in a way that flow naturally and allows for markup in the link text. The rest of the syntax is straightforward and can typically be picked up quickly. It's much closer, practically speaking, to how you would write a document using ASCII-based emphasis. As for difficulties it presents, there is generally no agreement on what the canonical flavor of Markdown is. The creator and much of the community has actively worked against this idea. As a result, there are several competing flavors. The closest to a standard is Common Mark, but it's not been fully adopted. In terms of documentation, MkDocs and other tools were not developed until relatively recently compared to Sphinx. This is the same document formatted in Markdown. Heading level is determined by the number of hashes at the beginning of the line. Link text is included in square brackets immediately followed by the link target in parentheses. And this renders on its own. So which one is better? Both REST and Markdown clearly have strengths and weaknesses, but as with many things, it depends on your situation. That said, the overwhelming adoption of Markdown by a broad range of ecosystems speaks to its capabilities. I would argue that if ease of maintenance and approachability are important to your project, Markdown is a better choice. I am not suggesting that Sphinx and REST are bad. I am saying, however, that it can become easier to make a decision to make a major shift when you are adapting to the flow of overall change. The Beware document migration process really began 2 years ago, though the bulk of it is more recent. For a little context, Beware is a suite of tools designed to enable you to write cross-platform GUI applications entirely in Python. I decided to start contributing at the sprints at PyCon US 2024. I struggled to find the documentation while preparing for my first call with the project lead to sort out how I might actually be able to contribute. This issue became the topic of the call and subsequently my primary contribution focus. Fast forward to the lead up to PyCon US 2025. We were dealing with issues related to REST, and the project lead remarked, once upon a time, REST seemed like a good idea, but I'm increasingly thinking moving to Markdown across the board would be worth it. When I followed up with full support, he quipped, if only we had a sprint coming up. Little did he know. That said, moving to Markdown across the board was not going to be a simple task. Beware is not a single library. It's multiple tools working under an umbrella. The Beware project has a website. Each of the tools have their own documentation. We use Read the Docs and GitHub Pages for web deployment. The Beware documentation infrastructure falls into 4 general categories: the tutorial, the 3 major tools, Toga, Briefcase, and Rubicon Objective-C, various standalone documents, and the website. This documentation structure may not necessarily be representative of your situation, as many projects only have one set of documentation. I'm going to share my experience shifting the Beware documentation infrastructure from REST and Sphinx to MkDocs and Markdown. I began with the website content. This conversion took a few hours at the PyCon US 2025 sprints. The Beware website was originally built using a system called Lector. Lector is a website builder that is halfway between a content management system and a static site generator. And it does default to Markdown for content. When the Beware website was created, the project lead went to great lengths to get it into restructured text mode to align with the rest of the documentation, which, as mentioned earlier, seemed like a good idea at the time. This was now a frustrating feature that made it a good first target for testing the viability of migration. The tools that I used for this were a markup format converter called Pandoc and a couple of features of the Lector API. The REST content was extracted using the API and was converted using Pandoc. The most important thing to come out of this was that it was proof it was possible to convert REST to Markdown with some level of automation. And this opened the door for migrating the entire documentation infrastructure. Preparation for the project took 1.5 months. When I began this project, the switch to Markdown was not a guarantee. My job in this was to explore the potential and prove it was possible. I went into this with the understanding that if I couldn't prove viability, the project would be scrapped. There were several pieces to the process, the details of which I will get into in the next sections. This included considering our back-end options, choosing and investigating MkDocs, creating a custom translation solution, exploring the add-ons that we would need to shape our docs, customizing and writing various migration tools, choosing what tools we needed to replace the various checks we were doing, and putting together a repo for shared content and tooling. The initial discussion involved a list of requirements and ideal features. Requirements included that the documentation be a static site, that the platform support translations, and that the overall setup have, at the very least, basic feature parity with Sphinx. High on the list of ideal features was direct documentation of type aliases. With that in mind, I considered our options. Sphinx does actually have content support for Markdown using the MIST parser. I also kind of had issues with Sphinx's error handling, and so the idea of shifting away from Sphinx completely sounded like a better idea to me than half shifting to Markdown while still using Sphinx. MkDocs is a static site generator. Okay, there we go. MkDocs is a static site generator built around Markdown and aimed at documentation. It definitely had the potential to fulfill our needs. As you look at other projects that are actively being developed, MkDocs comes out as the most common documentation solution. This includes projects such as FastAPI, Textual Enrich, CI Build Wheel, and Pydantic. I was offered an opportunity to look at the alternatives, and I chose not to. I chose to look at MkDocs first. So the first thing I needed to do was learn the basics of working with MkDocs. Once I had that down, I needed to establish basic feature parity with Sphinx. Verifying that most of the basic features were there was a quick process, but establishing full feature parity would take much longer. I chose very early on to figure out documenting type aliases. The project lead mentioned offhand that if this was doable, it would mean an instant approval of the update. This is because there are some features of the current Python typing experience that are not well supported by Sphinx Autodoc. While I knew this wouldn't actually guarantee approval, I'm always up for a challenge, and while it took some doing, I was able to get it working. One of the things we discovered early in the process was that the live preview build was quicker and more responsive than Sphinx had been. As well, unlike Sphinx, MkDocs was capable of tracking changes to the documentation in the source code in the live build without any decrease in performance. Another important piece was choosing the theme. There are several available, however, material for MkDocs had the most useful features and appeared to be the most actively maintained. I was confident at this point that a majority of what we needed was feasible with MkDocs, and with basic viability established, I turned to translations. MkDocs had a multilingual story, but no real translation story. The MkDocs recommendation involved having a local static translated copy of your entire site in Markdown for every language you required. This was not going to work for us. We were using an online community-driven translation front end called WebLate. And in order to make efficient use of WebLate, you need to present the content in translatable form, which means using GNU getText PO files. I found the Translate Toolkit, which is a set of translation tools provided by the WebLate maintainer. They allow for converting between, among other things, PO files and Markdown. Integrating the translation process into the build tooling would require writing wrappers around the translation build commands. We used Tox, a front end for executing project tasks in a clean environment, for running the wrapper scripts. This meant, among other things, that when we deployed the documentation to read the docs and GitHub pages, that what we were running locally mirrored what we were running remotely. And this was incredibly beneficial in troubleshooting build issues and failures. I was able to build a process that translated the content of the PO files to generate the associated Markdown in a temp directory, ran the MkDocs build process within, and generated translated HTML. This solution would evolve as the migration progressed, but we were able to build on the basic concept I initially provided. To reproduce our existing documentation, I would need to employ a number of extensions and plugins. These are the ones that were common to all of our projects. The attribute list extension added syntax to define attributes on the HTML output. This allowed me to apply CSS to any element by adding an ID within the Markdown. Autorefs added syntax for simple linking between pages. Macros is a plugin and mini framework meant to add macro and automation capabilities through the use of custom variables, macros, and filters. We made significant use of this add-on throughout the project. It enabled us to do things like customize the shared content experience through configuration variables and automate content creation based on metadata. The basic navigation built into MkDocs was not sufficient for our needs. Literate Nav allows for specifying custom page navigation structures in Markdown instead of within the YAML configuration file. For those familiar with Sphinx, MkDocStrings is the analog to Sphinx AutoDoc. For those unfamiliar, this is the plugin designed to extract the documentation from the doc strings in your code base. It has extensive configuration options, including things like overall formatting and how and what class and typing information is displayed. In terms of Markdown formatting, PyMdown extensions was critical. Also known as PyMdownX, it enabled us to do, among other things, code syntax highlighting, image captions, admonitions, collapsible content, tabbed content, and external content injection. The next step was automating the Markdown conversion. MkDocs makes use of quite a number of plugins and extensions, as I just showed, that apply Markdown formatting. Pandoc is, by nature, as a separate tool, unaware of the existence of these add-ons, and therefore doesn't know how to handle converting to exactly what was needed for our documentation. It took a lot of trial and error to figure out getting as close as possible. Pandoc offers several Markdown extensions that handle converting various elements of REST. CommonMarkX is Pandoc's implementation of CommonMark, which includes a specific set of the Pandoc extensions to cover features that aren't strictly part of CommonMark. It is possible to customize which extensions are included with CommonMarkX when running the Pandoc command. As well, Pandoc is designed to be run on one file at a time. I used find combined with Pandoc to enable running the command over all files in a directory. This is the command I used. The middle line shows customizing what extensions to use with CommonMarkX. You can exclude default extensions by using a minus before the name, and you can include extra extensions by using a plus. In this example, bracketed spans, smart, and alerts extensions have been excluded. I used Pandoc for the initial conversion, but that left quite a bit of work to do. I built a custom script of regular expressions to handle getting the Pandoc converted content to a MkDocs compatible state. This is one of the most obnoxious. I couldn't run Pandoc on the source code, so that meant converting doc strings entirely with regular expressions. There was a limited set of REST markup elements used in the doc strings, so I went through the source code to sort out what those were and handled each of them. This required special care to ensure that none of the source code was altered, and version control was invaluable here. The translations were also in a format that Pandoc wouldn't work with, so they also required a separate set of regular expressions. The biggest issue I ran into here is that there were many malformed REST links that had somehow been missed by the existing checks and caused issues with the script. This was yet another example of the building evidence that shifting away from REST was the right choice. I wanted to be able to verify and maintain consistency in our Markdown. I was introduced to a Markdown linter called Rumdle, which was very early in its development at the time. It had a number of issues, but also a phenomenal maintainer. I filed a number of issues explaining that I understood if they would prefer not to implement fixes because the problems I was running into were MkDocs specific. They opted to include a MkDocs setting that would encompass all the necessary features to work with MkDocs compatible Markdown, and we've worked together on improving that throughout this project. I chose PySpelling as our spell checker. It was more opinionated than our existing one and required a longer custom word list, but once that we sorted that out, it's worked smoothly. While it has other features, I'm using Markdown checker specifically to verify that web URLs are valid. The maintainer of this tool has been incredibly responsive as well. The Markdown checker can also validate internal Markdown links. However, MkDocs has its own internal Markdown link validation on build. As part of the preparation, one of the things we did was build a separate utilities project called Docs Tools. We built a basic website that exercises many of the features used in the rest of the documentation. This provides us with a testbed where we can test the impact of changes ahead of deployment. We also use this as a single source of dependencies for all the documentation. We made a series of customizations to the theme, and this allows us to keep that in one place and apply it across the board. The available tooling for injecting content from a separate location into the documentation meant that we could consolidate things like our contribution guide and our style guides into one place and have the same documentation across all projects. All of the build tooling, designed mostly around the translation solution, is maintained here. Just last week, we were chasing down a bug in a tool called Click, and in the process, found a workaround for it. The workaround involved adding a flag to the live serve tooling. If we weren't hosting all of the build tooling in one repo, we would have had to deploy this change across several repos. This is not the first example of this utilities project proving to have been a good choice. I could give an entire talk on this repo on its own. There is much more to what it does and how it works. If you're interested, feel free to reach out to me via any of the contact information provided at the end of the talk. That covers what went into preparing for the overall migration. At that point, I was given the go-ahead to migrate the tutorial. Once preparation was done, the actual tutorial migration took 2 weeks. This was a good first choice because it was, relative to the rest of the documentation, simple. While the documentation features of the tutorial are basic, they are all relevant to the rest of the project. For example, it consists of 8 sections that have interlinking between pages and includes codebox and tabbed content. The tutorial was already fully translated, primarily by human translators, so we did our best to maintain as much of that content as possible. The Toga migration took the better part of 2.5 months. Toga's documentation is the most complex and expansive within BeeWare. It has a large API. It also includes tutorials, reference guides, how-to documents, and topic guides. It required its own proof of concept. Early in the overall process, I created a draft PR showing the full conversion of 3 of the most complicated pages within the API. These pages contained examples of every element necessary to convert the rest of the documentation. Most of the work that went into this part was manual, as I needed it to be as complete as possible, and I was still working on building the conversion scripts. It took about 3 weeks before I was given the go-ahead to officially start working on it. As I said, Toga has a significant amount of API documentation. This would be our first use of MkDocs strings. This was one example of a vast improvement over the analog Sphinx feature. MkDocs strings resulted in an API documentation that was formatted differently than the existing, but ultimately we found it to be better. We also took the opportunity to do some additional housekeeping when a literal port of the old code would have been more difficult than a new option that would give us better outcomes anyway. For example, we had tables being built from CSV files, and they are now being handled by a YAML parser. One of the concerns heading into this was that there would be critical things missed during the migration process that wouldn't necessarily be caught on review. This was a major change. It involved a lot of files, and the only way we could guarantee everything was handled was with manual verifications. To ensure this, I went through the entirety of the newly rendered documentation site and compared it to the existing documentation site page by page. As expected, this caught a number of issues and a few edge cases. The complexity of Toga's documentation meant that this was a required step. With simpler documentation, it may not be a requirement. However, to do this on a simpler setup would take significantly less time, and especially if this is your first migration, I highly recommend it. Briefcase, on the other hand, took 3 days. This was due to multiple factors. The first being that the documentation is significantly less complicated, there is less overall, and there's no API because it's a user-facing tool, not a library. The second is that all the hard work had already been done. Everything we had built up to this point was more than sufficient to handle the briefcase migration, and it just worked. We did a similar manual audit at the end and caught very little in terms of issues. Rubicon Objective-C took about 2 weeks. This increased time was because it presented new problems to solve. While the documentation wasn't much more extensive than Briefcase, and Rubicon is Python, the code is written more like Objective-C. This oddness means treating the source code as documentation didn't work out so well. We managed to work around it using a typing file, which preserves the way the code is formatted and runs, but allows for presenting the documentation the way that we wanted it. Unusual code leads to unusual complications. The problems that we hit porting Rubicon are not representative of most of the problems that most projects will hit. Most projects are going to be more like Toga or Briefcase than Rubicon, and projects that hit complications like we did with Rubicon are going to hit their own unique set of complications because they're doing something weird with the Python language. That left the website, which took over 3 months. MkDocs is a documentation building tool. A website is ostensibly documentation, but with a more promotional focus. We wanted to maintain the general layout and content of the existing site. This meant essentially building it from scratch in Markdown, which is what ended up making this project take the longest. It stretched the capabilities of MkDocs, but ultimately we were able to successfully build the site. Content creation with Lector had its issues, which meant the team was less likely to keep up with things like event updates. We added some utilities to simplify content creation, which have significantly improved the experience for the team. Once this was landed, Beware was using MkDocs across all projects. This meant the look and feel of the Beware website and project documentation was unified, which vastly improved the user experience. Beware also has a set of standalone documents that were in REST. We addressed these throughout the migration process. We automatically generate release notes from change notes included with every PR submitted to specific projects. When we were running the change note system in REST mode, which meant the change notes were in REST, along with CI expecting REST to generate the changelog. Migrating this process involved converting all the existing documents to Markdown and updating the CI configuration to match. The most difficult thing to overcome here is the muscle memory of some of the team, as REST change notes still show up from time to time. We deal with it as it happens, but it's worth noting you can enforce Markdown formatting with a CI check. Briefcase as a project has a number of child repositories that contain REST that are templates that produce READMEs. The configuration for these templates required updating the content and updating them to produce Markdown READMEs instead. And every project also had a README in the project root that was REST. These were updatable using a simple pandoc conversion and were very straightforward to verify. It's easy to look at this as a purely technical change of markup language from A to B, but that's not the only story. It's also a social change because, as with any project involving a team, there is a human element to contend with. At the time that I started, I wasn't a member of the core team, and I was, in fact, a relatively new contributor. I had spent a number of years as a technical writer, but I had not worked on anything that I would consider substantive code. I wanted to shift Beware to Markdown across the board. The team wasn't so convinced. We had something that worked. Why change? This meant putting together a proposal solid enough to convince even the most recalcitrant member of the core team. I had to be prepared to address a continuing series of questions and concerns. This was not a single-step process. Rather, it was an ongoing discussion throughout. Presenting a successful proposal meant being able to show that the project was viable and that the results would be at the very least the same, if not better. Proving it was viable meant that it was deliverable, which goes beyond can it be done to can it actually be delivered. Something being doable means that an end state exists. Deliverable means there's a path to successfully get to that end state within the given parameters. In this case, that meant being able to land this without a single behemoth pull request. Don't get me wrong, there were several monster PRs necessary throughout the process. But overall, each step was kept as manageable as possible and sufficiently self-contained that if I needed to step away for whatever reason, the project wouldn't fall apart. I was the primary developer on the migration, and there's always a risk in open source that volunteers become otherwise occupied and projects are left unfinished. To that end, I proposed the process in stages. Each stage built on the previous. There were multiple changes to multiple projects, which could be done piece by piece, and we could opt out of any given piece at any time without negating all the previous changes. This enabled me to present this as a series of incremental changes instead of an all-or-nothing situation. In this case, incremental completion meant the inherent risk of me stepping away was significantly diminished. But the team wasn't the only human element. When it came to our READMEs, we took the time to create labeled good first issues on every repository with details on how to convert them. It did take work up front to create these issues, but it gave us an opportunity to engage with the community. We were successful. Our READMEs were almost all converted by members of the community. So how long did it take? The primary documentation infrastructure migration from inception to completion took over 9 months. Was it worth it? Absolutely. We are in a much better place. Incremental builds are lightning fast. Types are natively documented. The increased configurability of the API documentation was an immense improvement, including being easier to read, better laid out, and more customizable. Everything is in Markdown, which means the syntax is easier to consume. Shared content avoids previous duplication of content. The simplification of content creation means we are far more likely to write updates, and the documentation is now easier to maintain. Don't underestimate the amount of time and effort that went into this. It took a lot of one developer's time and a non-trivial amount of review and feedback from other developers on the core team to land it. So would we do it again? Unequivocally, yes. It is a set of changes that wouldn't have happened if I hadn't come along to do it, but they are absolutely worthwhile and have resulted in a vastly better developer experience for everyone involved. This leads to being able to more easily craft an improved user experience as well. Should you do it? That's for you to decide. Our process involved one developer. This is an implementation detail, not a requirement. This process could be easily split amongst multiple people and performed in parallel, significantly reducing the total time needed to do it. If you have the resources to do it, and it's not critical that the update lands tomorrow, it's a great sandbox to experiment in. It has clear success criteria that you take this thing and make it work in this other thing over here, and you can do an A/B switch between the two to compare and review. At that point, you can take it live knowing that it's exactly where you want it. I want to take a note to talk about the fact that MkDocs is currently in a transition period. MkDocs 1.0 is, or 1x rather, is no longer being maintained. There is a MkDocs 2.0, and it is not backwards compatible with 1.0. Proper Docs is essentially a fork aimed at preserving MkDocs 1x. Zensicle is new, but it is designed to be a drop-in replacement to the point of recognizing MkDocs configuration files as they already exist. The path to switching from Sphinx to Proper Docs or Zensicle would closely mirror what I've talked about today. All of the work discussed today would be necessary regardless of the solution you choose. Hopefully, I have given you an idea of the size and scope of what this change might look like for you and ways to approach it that will make it achievable. Here's where you can find me on the internet. That link at the bottom goes to my slides and the aforementioned resource list of links to all the tools and projects that were mentioned in this talk. Thank you.
There's no time for questions, but you can come talk to the speaker afterwards. Otherwise, enjoy.